I tested this off camera, and I made a little boo-boo. Here's a quick and dirty test rig to check out the optics. I just set the camera dead center in the hole there. And this is what I see. Everything's upside down, so the bottom is there. The right side is there. The left side is there. And the top is there. Jeez. It's in the way. The camera's not in the right place. It's too far up. The camera's specifications state that it has a field of view of 78 degrees. But what does that mean? Now, that can represent either the horizontal, the vertical, or the diagonal angular measurement. And an angular measurement of what? I think it's the diagonal measurement. Here, let me explain. All cameras take round pictures because they use round lenses, just like this microscope. Then they do this to make rectangular pictures. So a good portion of the field of view is wasted. Let's take out a piece of paper. We'll start off by drawing a circle, only in perspective, kind of. See how good I do. That's pretty good. Center would be about there. So we put it's got a center line. Didn't mean to make it so bulgy back there. What we want to do is come up here a ways and find an apex point and then make a cone out of this. Like that, see? Cone, there's your base. And there's your apex of your typical cone. Now, this thing is 78 degrees across there. It continues on. It's an infinite visual cone. Everything inside this cone, the lens will see. Everything outside of it, the lens can't see. 78-degree field of view. But we've got a rectangular picture. All right, like you're looking at right now. And it's at an aspect ratio of 16 to 9. And I like to work in 1080p, which means this is 1080 by 1920. Yeah, no big deal. It's the ratio of 16 to 9. Actually, the common divisor between both of them is 120. Whatever that means. Doesn't matter. What we're going to do is we're going to superimpose this on this picture here. Gonna a little rectangle like that. And that's approximately our 16 to 9 aspect ratio rectangle inside of here. Now what you can see is all the edges here are optically not used by that. It's not that the manufacturers leave these pixels blank on their chips. What it is their chips are like that big that fit inside that 78-degree cone. They're not stupid. You know. So anyway, what this does is this creates another geometric shape where this line here would be here, but there'd be a line from here to here, there'd be a line from here to here, and there'd be a line from here to here. And what it makes is a rectangular pyramid. See? A rectangular pyramid. Now, I haven't found any official term rectangular pyramid. So I guess we're going to have to call it a polyhedron, which covers a lot of territory. It covers this. So this is a polyhedron. So the polyhedron actually has sides that have angles, like that one, and angles on that side that we don't know. Now we can use trigonometry to derive this. We can take out our sines and our cosines and our And we can figure out what these angles are pretty easy if you're a math major. But we're not going to do that today. We're going to actually do just a practical test without any trigonometry, at least not at this point. So what we're going to do is we're going to take this camera. I'm going to pull these legs out. All right, then we're going to set it down real careful. We're going to put this leg in. We're going to put this in because I think it's a little too tall for our purposes. Cooperate with. There we go. Now, there we go. There. And this one, just make sure. Okay, and we're going to set her back up right here. And kind of like this. Then we're going to take this collar, bring it down flat. Of course, you know, this is all goes in. I don't want it to get up too high. We're going to take the camera and lower it so it's about perpendicular to the surface of the table. There we go. Let me just square the image up with the lens. There we go. We're squared up. Now we're going to grab this thing, precision measuring instrument, and we're going to measure the width of the image at the table. And we're looking like about 18 inches. All right. 18 by. And then we're going to get the other direction here. So we're going to come in from the top. And we're just about touching. And we're just about at the 10-inch mark. I'll call it 10 inches. 10. And one more. Last thing we've got to do is we've got to get the height here from the lens to the table. And I'm seeing 13 5/8. That's it. 13 5/8. So we can take these numbers now, pump them into our CAD model, and make this this polyhedron. I've taken those measurements and made the field of view polyhedron. Now, is anything in the way? You bet. The frame gets in the way here, just like what we saw in that test. So I think we can just lower the camera about 1/4 inch and everything should fall in place. Yeah, no interference anymore. But maybe we should drop it 1/2 inch, because if we add in the calculated FOV and polyhedron, you can see that potentially there's an interference with the bottom case. So much so that a bit of redesign is called for. We can see that a 78-degree FOV cone gives you about 44 degrees vertically, although we measured just 40 degrees. It's all still a little confusing, but at least we got some actual facts now. If you think about it, only the 4 corners of the image can be at 78 degrees. Also, the camera's designers probably didn't use the fringes of the field of view, which can tend to get a little fuzzy and aberrated. So they probably made their sensor a little bit smaller. Maybe that's why we measure 40 degrees instead of the calculated 44 degrees. That's some stuff, eh? So what do you say we just tear into that bottom case with all this in mind? So here we go. And there we go. There's our part. Put glue on the wrong side. Ah. All right, well, there's those two parts.